Let's get on with question 5. Climate change has been correlated with changing atmospheric carbon dioxide levels. Okay, so we're into topic 5. Scientists studying climate change have examined peat bogs. All right, so it's the first part of topic. Was it first part of topic 5? No, we're getting into the climate change and how we measure that climate is changing. So that's peat bogs. To observe pollen grains such as those shown in the photograph. Explain how studying pollen grains in peat bogs can provide evidence of climate change. Okay, so it does say explain, so it's not simply describe. We have to explain. Okay, so we have to explain and we have to go from pollen grains to evidence of climate change. Okay, so pollen is preserved in peat bogs, but why? Okay, why? Why is pollen? Because it says explain, the best prompt you can give yourself is why. So pollen is preserved in peat bogs. That's kind of basic principle of how you can use pollen as evidence of climate change. But why is pollen preserved in peat bogs? It's preserved in peat bogs because of due to the anaerobic, acidic conditions. Okay. So pollen is preserved, so it's preserved over a long period of time because the conditions in the peat bog are anaerobic, acidic. Okay, now the deeper the pollen, the more distant in time. Okay, so the depth corresponds to time. Let's just say it that way. Depth of pollen corresponds to time. And the species or types of pollen, as shown, we got in the diagram, we got lots of different types of pollen. So species and types of pollen, and its abundance relates or informs us about the climatic conditions. Okay, I think that's about it, right? Explain how studying pollen grains, maybe looking or observing pollen under the microscope. Observing pollen under the microscope can tell us, or observation of pollen under the microscope can tell us about which species of plant it came from. Okay, well, I'm really not liking my answer there. Okay, let's see how we've done. So explain how studying pollen grains in peat bogs can provide evidence of climate change. So pollen is preserved in peat bogs due to anaerobic lactic or anaerobic acidic conditions. So it prevents its decomposition. The depth of pollen corresponds to time. The species of pollen abundance informs us about the climatic conditions. And observing pollen under the microscope, observing its structure, for example, can tell us about which species it came from. All right, I think I've definitely got 4 points there, though I'm not super confident about that. All right. Scientists measured the productivity of two types of forest and recorded the mass productivity. Okay, so more topic 5 stuff. Productivity, remember that corresponds to photosynthesis and the rate of incorporating carbon into biological molecules. Productivity of 2 types of forest, and recorded the mass of carbon taken up per square meter per year. The table shows the data on the mean net primary productivity and mean gross. So we got NPP and GPP, so we might need our equation that relates to 2. So you've got 2 types of forest. So when I get a table, I first try and understand what the table is showing. So I've got 2 types of forest. And then we have the NPP, so that's the net primary productivity, and that's the GPP, and that's the ratio of the 2. So what do these numbers mean? Okay, well, the higher the NPP, the higher the net primary productivity. Why would you want to do a ratio of the 2? So, because really, you read a table going that way. So really the point of the whole table is this ratio. So what is this ratio telling us? Okay, maybe we come back to that. Calculate the percentage increase in mass of carbon released due to respiration. Now, when you've got parts of questions like this, they're usually related. So the answer you get in one part gives you a clue to what's happening in another part of this question. Calculate the percentage increase in mass of carbon dioxide released due to respiration by temperate deciduous forest compared with that by boreal forest. So what mass of carbon dioxide is released due to respiration? So what's our equation? GPP minus R equals NPP. Okay, so I could make a little column here for R, for respiration, because if I subtract, so if I do GPP minus NPP, it should give me R. If I just manipulate that equation, if I manipulate this equation, so I move R to the other side, so plus R on both sides, right? And then I minus NPP from both sides. That should give me GPP minus NPP equals R. So that's what I'm going to do. I'll need to get a calculator for that. Okay, so got my calculator now. So we've got GPP minus NPP. So 1013 minus 1013 minus 322 equals R equals 691 for boreal. And then we've got temperate deciduous equals 2165 minus 1301 equals R. So that's RB, and that's RT equals 2165 minus 1301 equals 864. Percentage increase in mass. I don't love this question because it's completely different places, so it shouldn't really say percentage increase because it didn't really increase, it's a difference, but whatever. Now, so when we got these 2 values and they're saying one compared to the other, all right, so which way round is the important question? By temperate compared due to respiration by temperate deciduous forests compared with that by boreal forests. So I think The boreal therefore becomes our original value, and they want to know what the temperate one is compared to the boreal, so that we'll treat our temporal or temperate deciduous one as the new. So whenever you've got percentage difference, you always have to figure out which one's your original value and which one's your new value. So we're going to go with 864 new minus original divided by original. So 864 minus 691 divided by 691 multiplied by 100 should give us the percentage, and I will chuck that into my calculator. 864 minus 691 equals, divided by 691 equals, times 100 equals 25. 25%. 25.03%. Okay. Right. Right. Next, the ratio of net primary productivity to gross primary productivity is a measure of the ability of forests to transfer carbon from the atmosphere into biomass. Okay, so now we have the significance of these numbers. Scientists concluded that temperate deciduous forests would reduce levels of carbon dioxide in the atmosphere more than boreal forests. Justify this conclusion. Justify means give reasons why it's right. Okay? Justify means give reasons why that is correct. So, what is it that they're saying? The temperate deciduous forest would reduce the levels of carbon dioxide in the atmosphere more than boreal forests. Give the reasons why that is correct. Okay. So the first reason is the temperate deciduous forests have a higher ratio of NPP to GPP. Okay. So temperate deciduous have a higher ratio of NPP to GPP. Okay, so that's the first reason. Now we need to think of two more things. Okay, any other reason? Is there anything else that they're doing more? Well, the other thing is that they do have a higher GPP. Okay, so temperate deciduous do have a higher GPP. Anything else? Well, they also have a higher NPP. Also have a higher NPP. Reduce levels of carbon dioxide in the atmosphere. Okay, so basically the temperate deciduous forest is more productive. Okay, so because the well, let's just think about this ratio. Because the ratio is bigger, because the ratio of NPP to GPP is bigger, that means okay, yeah. So let's just think about this now. So basically GPP is essentially all of the carbon that is fixed into biological molecules. Yeah. Now, the bigger the NPP is, that means the less or the lower the R value is. Okay, so the higher the ratio, that means the higher more of the productivity. There's lower respiration. So because the ratio of NPP to GPP is bigger, that means there is a lower production of CO2 or carbon dioxide, lower production of CO2 due to respiration in that forest. This means more CO2 would overall be fixed into biomass okay, but there I'm just repeating what's in the question, so I don't know if I would get marks for that. We have 3 marks, so we've said that there's a higher ratio of NPP to GPP. We've got higher GPP, and we've got more NPP, but that means, I think the main thing is that there is a less carbon dioxide kind of produced as a result of respiration. This means that a greater percentage, so yeah, I think a greater percentage of CO2 absorbed is converted to biomass. But it's more about the balance, isn't it? It's more about the balance. Right, I was not happy with that. I haven't seen the mark scheme, but you're just gonna have to trust me on that one. There's really no point me doing this if I have seen the mark scheme. But on this occasion, okay, I'm just having a look at that question. So I think the logical, okay, and we got to try and make this logical, because it can't just be just writing down stuff that we think is right. I think we've got to have a structured approach to this. So let's look at this again. Justify this conclusion. The ratio of the net parameter. Okay, so TD ratio is higher than boreal. Okay, the temperate deciduous ratio is higher than boreal. What that means, so we're using some information and we're adding value. All right, okay. The ratio is a measure of the ability of the forest to transfer carbon from the atmosphere into biomass. So my next point is going to be TD is therefore is a measure of the ability. TD has a higher rate of transfer of CO2 into biomass. So I'm using the wording of the information that's being given to me to kind of make my points a little bit more direct. TD ratio is higher than boreal. TD has a higher rate of transfer of CO2 into biomass because, okay, but I know I'm justifying. Do I need to be explaining? Possibly I do, because it connects to my knowledge and it justifies the answer. So higher rate of transfer into biomass. TD ratio is higher. That means that means the GPP and NPP values are closer together, which means R is smaller, okay? And if R is smaller, then less CO2 is produced due to respiration in the temperate deciduous forest. Okay, I think I'm happier with that answer than the other one. Okay. Justify this conclusion. Okay. All right. Okay. I think I'm happy with my answer.